So, we will continue our discussion on the Millikans Weld-Off experiment, this very famous experiment for measuring accurate charge of an electron. So, Millikans Weld-Off experiment. Okay. So, what was that experiment? So, this basically this Millikans, what he did, he used charged oil drops, and now these charged oil drops, it spread in space. Okay. So, it spray in space using spray or atomizer, it is called atomizer. So, very small tiny oil drops was produced and thrown in space. Okay. Now, what will happen? These oil drops will fall, there will be free fall of oil drops due to the gravitational force, downwards force, gravitational force, that is basically if mass of the oil drop is m and gravitational force is g, acceleration is g. So, mg, that will be the force acting on the oil drops. So, now use atomizers to produce very small oil drops. It is not only one oil drops, many oil drops, and they fall, free fall. Okay. So, they free fall. So, they are falling downwards. Okay. So, all are falling. Okay. Now, he used capacitor plate, again 2 metal plate, keeping hole on top plate, Okay. So, this must be parallel, and then he applied voltage, high voltage, it is high voltage. Okay. So, this volt was around V equal to say 5000 volt. 5000 volt is very high volt. So, our in our house whatever electricity we are using, this voltage, you know, this 220 volt. Okay. Single phase having 220 volt. So, it is very high volt compared to that. Now, what will happen? Depending on the distance between these two capacitor plate, now there will be electric field between these two capacitor plate. So, this way basically we generate electric field. So, here electric field is applied on this oil drops. Then he found that if this top plate is positive and bottom plate is negative, then what he found, that these oil drops are moving up, Okay. So, that means these oil are negatively charged. So, electric field acting on this charge, and it is this force will be upward and it will move. If that force is greater than the gravitational force acting downwards, so net force then will be upwards. So, net force will be is if the charge of oil drops is q, so the force will act, upward force will act, that q e. Now, resultant force will be q e minus m g, acting upwards. So, that will be force when electric field. So, this is the force is downwards without applying electric field, and when electric field is applied, so it will be upwards when this q e is greater than m g. Otherwise, it will remain downwards because of this higher force, gravitational force. Anyway, so when there is no electric field, so this is the force, mg force is acting downwards, and when, and it is falling through a medium, air medium, it is falling through a air medium. So, when any particle moves through a medium, so there is a viscosity of this medium, and it reaches to a terminal velocity, and this is basically it is the Stokes law, and that if that velocity is v1, this force is acting F mg equal to mg, okay, downwards, and then Stokes law is basically it tells that it's there will be resistive force acting in opposite direction due to the viscosity, okay. So, when downwards force and upwards force, so there will be so these two force, one is resistive force and another is downwards gravitational force, and due to these two force in viscous medium, so this particle reaches to the terminal velocity. What is that terminal velocity? Terminal velocity, these two force, as if they will, resistive force and this downward force, they will be balanced. There is no net force on the particle. So, if there is no net force on the particle, then there will not be any acceleration, then there will not be any change of velocity. So, whatever velocity it reach, that is called terminal velocity. Now, with that velocity it will move. So, that is the terminal velocity. Okay. So, to get that terminal velocity, condition is that this force will be balanced by this resistive force. What is the resistive force? This 6 pi. So, this is the from Stokes law, it is 6 pi eta viscosity constant, and the radius of this particle, spherical particles, here it is oil drop. So, 6 pi eta or v1, say terminal velocity, v1 is terminal velocity. Okay. So, this the situation will arise, and so this will move downwards without acceleration, but with terminal velocity, and this Millikans, what he did, he measured this terminal velocity V1 without, when there is no electric field, in that condition what is the terminal velocity V1, he measured experimentally. How he measured? He used microscope, and in microscope there is a eyepiece, in microscope there is eyepiece with scale. Okay. Now through microscope he sees that with time, for a certain time, what is the distance it is traversing, So, distance, and for that time, so he found the velocity. So, experiment is not very, so many times he has to measure, he has to reproduce the result. Okay. So, that way using microscope with scale in eyepiece, so he found this value, terminal velocity. Okay. So, that is basically V1 found through microscope. Okay. Microscope. What is the, say, for time t, what is the distance it is traversing? Okay. So, he measured this x for a time t. So, he gets this V1. Okay. So, when, what is this m here? Here m I have written, that is basically effective mass of the oil drop, Why? So, you know Archimedes principle. Okay. So, whenever this any particle, it is in a medium, easy to understand liquid. Okay. So, it lose weight, right, it is because of buoyancy, Okay. Buoyancy force, it is upward basically. Okay. So, because of this buoyancy force of this, in this case it is air. So, this is effective mass m is basically this, what is mass? Mass is basically the volume into density. If density of this oil is rho of oil O, and this effective mass will be then is minus rho density of air. Okay. So, that will be the effective mass m, right. So, what we are getting then from 1 and 2, we can write from 1 and 2, so you can write R1, because R1 is not known to us, So, R1 I can write R1 equal to, so if I replace this m by this, so I can see R cube in this side, here R1, so R1 square. Okay. So, basically R1 square. So, R1 will be something in this bracket and then to the power half. Okay. Now, this side 6, this side 4 by 3. Okay. Then 9 by 2, it will be 9 by 2. Then this side pi is there, thus that will go. Now, this side eta is there. So, eta will be there, V1 will be there, V1 will be there, okay, divide by this, divide by rho 0 minus rho A, okay, 0 minus A, okay. So, and one G will be there. So, this side G is there. So, I think I have to write here G. So, from here this is the expression of R1. R1 one can find out because G is known, rho 0, rho A is known, eta is known, okay. If V is known, V1 is known, so then one can find the R1, okay. So, experimentally he measured this V1, so from here one can find out R1. So, now if we apply electric field, and then what will happen? As I told, the direction is chosen in such a way, this electric field, that force will act upwards. So, this will be the resultant force, this will be the resultant force, okay, acting upwards. Now, due to this force, it will move upwards. So, now net force is acting upwards. Due to this force, again this mass, this oil drop, it will reach to the terminal velocity, because it is moving through the viscous medium. So, there will be resistive force. So, I can write this, the QE, that force, net force upward, QE minus mg, because so that force will be balanced by 6 pi eta R1. Now, terminal velocity, that will be different, V2. Now, terminal velocity will be different, V2. Now, from one and from this equation and this equation, now if I tell this is the equation 3 and this is the equation 4. Now, from 1 and 4 you can because 1 I need here. So, I can get Q E equal to this plus this is nothing but this. So, I will get Q equal to 6 pi eta R1 into V1 plus V2 divide by E, divided by electric field, right. So, that will be the expression for Q. And electric field, of course, that electric field, of course, earlier I mentioned electric field will be V by D if this separation is D. So, one can get one can write E is E can write into D by V. There is voltage and that is the separation D by V. Okay. So, now in this there is the final equation for charge in oil drop. In this expression R1, one can, in principle R1 is this, and here you can see everything is known except V1 and V2. If we know V1 and V2, right, if we know V1 and V2, then you will get the charge Q. you will get the charge q, and he found the charge from he measured on many oil drops, and he found the charge is always multiple of some unit charge, Okay. So, these q are different for different oil drops or sometimes same, okay, whatever, but it is always Ne, it is the integral multiple of E, unit charge, some charge, okay. And that E he found, E equal to that value, E equal to minus 1.6 into 10 to the minus 19 Coulomb, okay. So, this again very beautiful experiment, and from this experiment one can measure the charge of electron very accurately, and that is what the greatness or famous, that is why it is a very famous experiment, and this experiment gave very exact value of electrons, okay. So, so this is the oil drop method. So, what we learned from last class and this up to this. So, we learned how the electron was discovered, okay, and what is the charge and mass of electron, and this took so long time. You see, Faraday experiment, that was in 1833, you remember 1833, and just mentioned about the presence of what is called this existence of the charge in nature, okay, in matter, okay, and in 1897 and then 1897 and then 1909, okay. So, only this time, so it's almost 80 years time it took to find out the charge of electron and mass of the electron. So, next I will go for how. So, this we want to know the constituents of an atom. So, one is electron and how it is discovered, that I have discussed. Next, discovery of proton, another constituent of atom is proton. So, how it was discovered? So, in 1909 Rutherford discovered proton in his famous gold foil experiment, you know. So, it is another famous experiment, gold foil experiment, and so how this experiment is it's easily understood. So, that I will explain what was that experiment and how he discovered this proton in that experiment, okay. So, next experiment is Rutherford's gold foil experiment. Okay. So, Rutherford gold foil experiment, Okay. So, foil is basically sheet, very thin sheet, okay. It is called foil, aluminum foil, you know, aluminum foil we used to pack our food, okay. So, this very I think this foil is maybe thinner than that one, aluminum foil. Okay. So what he did, he alpha particle, radioactive material, it emits alpha particle. So, alpha particle, he took the source of alpha particle, he took the source of alpha particle, source of alpha particle, okay, is basically its mass is 4 and its charge, positive charge is 2, okay, alpha particle. I think this way we write, okay, its charge is 2, positively charged. So, this alpha particle, he from a source he took and it is bombarded a foil, it bombards a foil. I think I will, okay, this gold foil, this is the gold foil, this is the gold foil, okay, this is the gold foil. He put gold foil, this alpha particle, it is coming and hits this gold foil, okay, and then he studies the scattering of this alpha particle. After bombardment on this foil, how that alpha particle are scattered. So, that is what he studied, okay, and he found that so he put basically I think he put some fluorescent screen in a tape in a circular form, okay. So, let me try to draw, but I do not know whether I can draw nicely. So, let us say it's okay, and then what I do, okay. No, I think this is basically foil. It is made of that, I think he used this foil. It is not gold foil, it is the screen, but it is coated with zinc sulphide, it is the fluorescent material. Okay. So, just it is the tape kind of things, just suddenly it is put in circular form. Okay. Now, this alpha particle bombard this foil. Now, this they are scattered, so many alpha particles are hitting, and he found that, and then after scattering from this foil, they are hitting this screen, they are hitting this screen. So one is, so this in, so there are many. Okay, so there are hitting, and so it's scattered. So okay, so these so many alpha particles are coming and hitting this gold foil, and then they scattered, and he found that most of them scattered without deviation, just as if it is there is no foil, they are passing through the foil without scattering, without deviation. But there are very few alpha particle scattered in backward direction, very few, one in 20,000, 1 in 20,000 alpha particle scattered in backward direction. So as if you see this one foil you have taken, so one particle, alpha particle, and gold foil, its atom, gold atom have higher mass, right, and alpha particle have lighter. Okay, so it is not easy to pass through it, through this foil, right. So it was expected that most of them will be backscattered and very few will pass through it, but result was just opposite. Most of them pass through it without deviation or deviated with very small angle, and 1 in a 20,000 alpha particle just get backscattered at nearly 180 degree. Okay. So this result was what it is telling. It is telling that this, so this foil is made of atom, its substance is made of atoms. So atoms are arranged in this foil, that is clear. Now if atoms are solid, okay, like spheres, solid spheres, then alpha particle should come back, but it is not coming back. Opposite result we are seeing, they are passing through it. So they have to pass through the atom, right. So that's what Rutherford conclude that atoms are space in atoms are mostly vacant, is free space. So all mass of the atom, it is concentrated in a very small place in atom. So most of the atom, if this is the atomic size, okay, most of the atoms are free space, and only this its mass, because atom has mass, weight, right, that we know. Now how this mass is distributed? So from this experiment it is telling mass is not distributed over all this atom, Okay. This mass, whole mass is concentrated in a very small place. So, that he called that this is the nucleus, is the nucleus of atom, is the nucleus of atom, okay, and rest of the part of the atom are, there is no mass in rest of the atom. So, size of atom is bigger, and compared to this size, this whole mass is concentrated in a small space. Okay. It is like this. If it is this the size of the atom, this mass is concentrated in this. So, this part is called the nucleus. Since atom have electron, it is discovered, and atom is neutral. So, he then told that nucleus is nothing but the, in nucleus is whatever the it is nothing but the proton is having positive charge. So, mass, so that is why this electrons are there in atom, and then mass, it is the lighter atom, Now, this whole mass is concentrated in a place, this is called nucleus, and this particle, another particle, it will have the positive charge and mass, higher mass and positive charge and higher mass, and this particle he called the proton. This positive charge was considered because this atom has to be neutral, and already electron is discovered. Okay. Thus, from this Rutherford experiment, mainly it was found that this whole mass of the atom concentrated in a very small place, that is called nucleus, or this new particle, and this new particle has to be positive charge, because the overall atom is neutral and negative charge electrons are there. Okay. So, exactly opposite charge of electron, that is, and higher mass, whole mass of the atom is concentrated in proton, is nothing but the another particle, that is the proton. So, that is why this proton was discovered. So, I will stop here. Thank you for your attention.